Hi, my name is Mark Lance. I teach math in an adult education program in New York City. I've been doing this for 22 years and I'm really committed to seeing my students get their high school diplomas and go on to get better jobs, go to college, and satisfying careers. Some of my students over the years have suggested that I make a video so that they could go back and review things that we did in class, and maybe you'll be interested in doing the same thing. I hope so. Today I want to talk about fractions. Most of my students hate fractions, but I like them. There's a lot of math in them. They show up in lots of places in everyday life. They show up in a lot of places in math, and they show up on your GED test. So for starters, what are fractions? Fractions are simply numbers that are on the number line or appear between the whole numbers. So here's a number line that has a bunch of fractions in it: 0, 1/2, 1, 1.5, and so forth. Okay, so these fractions are in between the whole numbers of 0 and 1. 1 and 1/2 is between 1 and 2, and so forth. So this problem, which is a very typical problem that I actually got from a GED practice book, gives this number line. Some of the points are identified, some aren't, and then it asks this question: which of the following is the decimal point value of the dot on the line above? There's the dot. So even if you're not an expert in fractions yet, you could still answer this question. Don't get intimidated, don't let the wheels fall off. You know how to solve this problem. So if this is 0 and that's a half, maybe think about money. Here's no money and here's a $50. What number comes right in between that? Okay, a quarter. Think about real money. Here's 0 money, here's a quarter, and there's a half. If that's true, then this is probably, add another quarter, this is probably 3/4, add one more, and it's 1. So that seems to work, that each one of these lines represents a quarter. So if we move up the line here, so here's 3, this must be 3 1/4, this would be 3 1/2, this would be 3 3/4. And if you think about money, here's our possible answers. There's 3 3/4. Okay, so you could answer this question just by sort of using common sense and understanding that number line. Okay, let's move on from that. And next thing I want to do is talk about some basic terms. So in a fraction, the top number is called the numerator. You can sort of hear the word number in there. And the bottom number is the denominator. Okay? So fractions can be, so for example, in this fraction, 1 is the numerator and 2 is the denominator. So fractions can be various things. They can be part of a whole. So here's a whole pizza. I have a lot of pizzas in my classes. This kind of pizza. And you can see that there are 8 slices, which is how most pizza guys cut their pizza in a pizzeria. So since there are 8 slices, each of them is an eighth. But the number of slices, no matter how many you have, how many slices you have, the number is 8 because the pie has 8 slices. That's saying that there are 8 slices in this pie. The numerator is how many slices you have. You could have 1 slice, and that would be 1/8 of a pie. Maybe you're still hungry. You have another one. Now it's 2/8, and so on. 3/8. All the way up to all 8 slices. 8 slices in the pie, you ate all 8 of them, or 1 whole pie. So just to repeat, a fraction can be part of a whole. It can be a probability. For example, if I have a coin, you're trying to figure out the odds of it coming up heads. There's 2 sides to the coin, only 2. You pick heads. There's only 1 side that has heads on it. The likelihood, or the probability of your winning the coin toss is 1 out of 2. 1 head out of 2 sides. Nope, that didn't work. Maybe we'll cut this part out. Anyway, heads. 1 out of 2 chances. So it can be a part of a whole. It can be a probability. But it is always a division problem. Okay? This means 1 divided by 2. If we do this division problem, or you ask your calculator, 1 divided by 2 is going to be 0.5 or 5/10 or 1/2. Now, a lot of my students say, well, you can't do that. You can't divide a bigger number into a smaller number. That 2 isn't going to go into that 1. Well, it's not all going to go in there, but half of it's going to go in there. You can certainly take a candy bar, 1 candy bar, and you got 4 kids. That's 1 candy bar divided by 4. If you ask your calculator what that is, calculator is going to say 0.25, a fourth. Each kid is going to get 1/4 of the candy bar. Okay? So a fraction can be part of a whole, it can be a probability, try not to drop the coin, and it can be, and there's always going to be a division problem. Okay? All right. So let's actually look at a fraction problem. Now, to start with, in my classes, I always use just plain numbers, or sometimes I call them naked numbers, as opposed to word problems. So once we get comfortable and confident in doing these problems with just numbers, then we'll go on to other problems, word problems, which are more like what you're going to see on the test. But I like to start with this. So let's say we're going to add the fraction 1/8 plus 3/8. Okay? Well, since the denominators in both cases are 8, we can just add 1 plus 3 is 4. Here's our pizza again. You started with 1/8, and then you had 3/8 more. 1, 2, 3, and you've had a total of 4/8. And there it is, 4/8. Okay? So this is just like any addition problem, like adding 1 apple and 3 apples is 4 apples, okay? In this case, we're adding not apples, but eighths, okay? And we get 4/8. Now, the thing to remember here is that fractions can have more than one name for the same value. And this is called reducing fractions to lowest terms. And what that means is there another name for this fraction which has the exact same value? You might be able to guess what that is, because 4/8, how much of the pie is that? So what we do is we look at these two numbers and we ask, is there some number that goes into both 4 and 8? And maybe you recognize that 4 goes into both of them. 4 goes into 4 once, 4 goes into 8 twice, 4/8 and 1/2 are the same. If you ask your calculator what's 4 divided by 8, it's going to say 0.5. If you ask the calculator what's 1 divided by 2, it's also going to say 0.5. This is important for a couple of reasons. For one, on your test, if you have a problem like this, the directions are probably going to say that all fractions must be reduced to lowest terms. So if you did this problem and came up with 4/8, they would mark it wrong. Or maybe you wouldn't even see it in the multiple choice. You'd look down and you'd say, I don't see 4/8 anyplace. But you have to realize that 4/8 is the same as 1/2, that would be the correct answer, okay? The same thing would be true in a subtraction problem. So let's see here, we could do 7/9 minus 4/9, okay? Well, the denominators are the same, so we can just get right to work. 7 minus 4 is 3, and we're talking about ninths, so 3/9. That answer is true. It's correct, it's accurate, but they would mark it wrong on the test. Why? Because is there some number that goes into both 3 and 9? Yeah, 3. 3 goes into 3 once, 3 goes into 9, 3, and that would be the correct answer. These are the same, but this is the only one that's the right answer on most tests, okay? Now, in these problems, both addition and subtraction, it was easy to do because the denominators were the same. In this case, both of them were eighths. In this case, both of them were ninths. But that's not always going to be true. So the last thing I want to look at is, supposing we have a problem that said add 2/3 plus 1/4. All pretty simple numbers, not too hard to do, but they're not the same denominator, so we can't just go ahead and add them. So what we have to do, we have to see if we can find another name for each of these fractions that has the same denominator. So how are we going to find what that number is? Well, you might just realize from remembering your times tables that both 4 and 3 go into the number 12. And it's true. 3 times 4 is 12, 4 times 3 is 12. Okay, so there's a common denominator we can use for both of these fractions. Another way to get the common denominator is to multiply these two denominators. If you multiply 4 times 3, that will give you 12. And that will definitely be a common denominator. It might not be the lowest one, but it'll definitely be a common denominator. But we got lucky on this one. It is the lowest one. Somebody might say, well, what about 6? 3 goes into 6. That's true, it does. But 4 doesn't. So it's going to be 12. Question is, what's the numerator going to be? So there's a lot of ways to do this problem, and any problem. I'm not saying this is the only way, and if you have another way that you're comfortable with that works for you, I'm not trying to get you to change it. But here's how I try to explain it. What do you have to multiply this 4 by to get 12? 3. Okay? 3 times 4 is 12. And whatever you do to the denominator, we're going to do the same thing to the numerator. Okay? You could also do it as a division problem. 12 divided by 4 gives you 3. Okay? So we do the same thing on the top and the bottom. We multiply this by 4 to get 12, so we're going to multiply this, by 3 to get 12, so we're going to multiply this. 3 times 1 is 3, and 3/12 indeed is the same as 1/4. Okay? We're going to do the same thing up here. What do we have to multiply 3 by to get 12? 4. 4 times 3 is 12. So we're going to do the same thing up here. 4 times 2 is 8. Okay? And now we have a common denominator, and now we can add them. Now before we know it, we can see what the answer is. It's going to be 11, because 8 plus 3 is 11. And the common denominator is 12. But I'd just like to say in passing, what gives me the right to do this? Well, if you remember that all fractions are division problems, 3 divided by 3 is 1. So I'm really just multiplying this fraction by 1. I'm not changing the value. I'm just changing to another name for 1/4 so that we can have the same denominator for both fractions, okay? And up here, we multiplied it, both the numerator and the denominator, by 4. 4 divided by 4 is 1. So now we have two numbers, common denominator, and now we can add them. 8 plus 3 is 11/12. Okay? All right. Lastly, let's do 3/5, and you can stop. One good thing about doing these videos is you can stop it at any time. If I say, well, what's the answer going to be, you can stop the video and see what you get, and then start it back up, see if we agree. Or you can back it up and repeat it. So that's one of the reasons why I like videos for teaching. So let's add 3/5 plus 1/4. Okay? Can't just add them because the denominators are different. So again, how are we going to figure out what number? We're looking for some higher number that both 4 goes into and 5 goes into. And you might have realized already it's 20. Does 5 go into 20? Yeah. Does 4 go into 20? Yeah. Is there a lower number? Maybe 10 would work. Does 5 go into 10? Yes. But 4 does not go into 10. So we're going to stick with 20s. And we're going to do the same thing we did the last time. And even though this seems like a lot of steps, the more you practice, pretty soon it'll be easier and even obvious to you. You won't have to go through all this. But I like to go step by step until people get confident about it. 20 divided by 4 is 5, or what do you have to do to that 4 to get 20? You're going to multiply it by 5. Well, whatever we do down here, we're going to do up here. 5 times 1 is 5. What gives me the right to do it? Because 5 over 5 is 1. So that's 5/20. This, we're going to multiply both sides, both numbers rather, by 4. 4 times 5 is 20. Do the same thing up here. 4 times 3 is 12. We have 12/20 plus 5/20, and now we can add them, and and we come up with 17/20. And that can't be reduced. Nobody can come up with a number that goes into both 17 and 20, so that's our final answer. There's no reducing, okay? And lastly, we'll just do a subtraction one, which sometimes is exactly the same as addition. Sometimes it's a little trickier with an extra step, but we'll do that in the next lesson. So let's say the problem says 7/9 minus 1/2, okay? Need to find a common denominator. You might think to yourself, what's the first number you can think of that both 9 and 2 go into? And you probably come up with 18. Or you do it the other way, 2 times 9 is 18, that tells you it's a common denominator. So we both denominators are going to be 18. To turn 2 into 18, you have to multiply by 9. We'll do the same thing on top. 9 times 1 is 9. And if you think about it, 9 over 18, or 9/18 is the same as 1/2, which it should be. Same thing down here. Multiply 9 by 2. That gives us 18. That tells us we're going to multiply the numerator by 2. We have 14/18. And now we can do our subtraction. Denominator is going to be 18. 14 minus 9 is 5. 5/18 is our answer. And again, it can't be reduced. Okay? So that's a good start for us, I think, in understanding what a fraction is, and including adding and subtracting fractions when you don't have a common denominator. And we can do more complex problems. Maybe next time we'll do an addition problem that has more than 2, 3 or 4 even. Same steps, it's just a little bit bigger. Okay? So I hope you find that helpful, and in your studies as you prepare for your GED test. Here is a email address where I'd be happy to hear from you, and if you have suggestions of other lessons you particularly like me to do, I'd certainly consider them and probably get to them at some point. And finally, this reference to the Weber House is talking about this book. It's a mystery that I wrote. It's a mystery set in Maine. Has the protagonists of the story are 2 13-year-old girls who overcome prejudice and superstition to solve a centuries-old mystery involving pirate treasures, and there's even some math in it, so you might like it. The website, which we'll post below, you can look at it below on the screen. You'll find out all about the book and me as much as you want to know if you go to that, theweberhousemystery.com. And for any questions or comments or suggestions, go to theweberhouse@gmail.com. And I'll be looking forward to hearing from you. Thanks.